Hi students, welcome to Chemistry Online. Today we are going to discuss polarity of bonds. Polarity of bonds. Okay. So before going to discuss polarity of bonds, you have to know covalent bond. How many types of covalent bond means two types of covalent bonds, polar covalent bond and a non-polar covalent bond. So here you have to know first covalent bond. Covalent bond. Covalent bond means sharing of electrons. It is two types. Okay. First one is nothing but polar covalent bond. Polar covalent bond, and second one is nothing but non-polar covalent bond. Okay, so polar covalent bond means so explanation. Explanation. If you take X is an atom having one electron and it is reacts with the same atom which having one electron, gives rise to X bond X, and sharing of electrons takes place. So X2 molecule is formed. It is atom. It is atom. It is a sharing. It is a sharing. It is a molecule. Okay. So one electron pair is shared by two same atoms. Then that is nothing but a non-polar covalent bond. So it is a non-polar covalent bond. Non-polar covalent bond. It is a polar covalent bond. So here, so non-polar covalent bond and polar covalent bond. So, okay, see here, what is a non-polar covalent bond means if one electron pair is shared between the two same atoms, the result non-polar covalent bond is formed. See, non-polar covalent bond is formed means electron pair is equal distance to this nucleus of an atom and this nucleus of an atom. Electron pair is located same distance to the both the nucleus of atom. Okay. Then for example H2, N2, O2, Cl2, I2, all these are non-polar molecules. Non-polar molecules. Here, hydrogen having one electron reacts, this hydrogen having one more electron, then sharing hydrogen, single bond hydrogen is formed, then H2 molecule is formed. Here, electron pair is centrally located between the two atoms. Okay, this is a non-polar covalent bond. Next, polar covalent bond. So here electron pair is one electron pair is shared by two different atoms. One electron pair is shared by two different atoms. Then that is nothing but a polar covalent bond. So here X having one electron plus Y having one electron then sharing takes place, XY molecule is formed, XY, it is a molecule, this molecule is formed, then here it is a sharing, then it is a sharing, it is nothing but a non-polar covalent bond. Now electron pair is nearer to the one atom's nucleus. Here electron pair is nearer to the one atom's nucleus. So this is nothing but a non-polar covalent bond. Non-polar covalent bond. Why? Because here electron pair is displaced, not in center between the two atoms nucleus. So in this polar covalent bond, electron pair is nearer to the one atom. So that is nothing but a polarity. It is nothing but a polarity of the bonds. Why this polarity is called? So here it is, for example, it is a atom, it is a atom different, it is a molecule, it is a sharing. For example, H2O, NH3, HF, all these HCl, all these are examples. So if you take HF, hydrogen having one electron plus fluorine having donating one electron, then sharing takes place. Then sharing, it is a sharing. Due to sharing, HF molecule is formed. Here electron pair is towards nearer to fluorine atom. Why? Because its electronegativity value is 2.1, its electronegativity value is 4. Due to high electronegativity value, it attracts the electron pair towards its nucleus. So due to attracting, it gets positive delta, it gets negative delta, means a charge will be developed on the atoms. It is a positive charge, it is a negative charge, means it is nothing but one pole, it is nothing but another pole. So a displacement of electron pair is nothing but a dipole moment, that can be indicated by crossed arrow. This is called dipole moment. Dipole moment and denoted by mu. So dipole moment indicated by this type of crossed arrow. Here cross arrow. Dipole moment is indicated by crossed arrows. Now electron pair is pulling towards from hydrogen to fluorine. That's why we are keeping this type of arrow. Now electron pair is moving from hydrogen to fluorine. It indicates electron pair is moving from hydrogen to fluorine. So this is nothing but a polarity of bonds. So covalent bond is two types of non-polar covalent bond, polar covalent bond. So non-polar means electron pair is sharing between the two same atoms. So polar covalent bond means electron pair is sharing between the two different atoms. So a displacement of electron pair can be takes place, that is nearer to the one atom's nucleus, that is called a dipole moment. Dipole moment is denoted by mu, that indicates cross arrow. Now we are going to discuss dipole moment. Dipole moment, which is denoted by mu. Dipole moment, which is denoted by mu. So dipole moment mu equal to dipole moment, it is explanation. Explanation, mu equal to Q into R. Or dipole moment mu equal to E into R. E into R. So here Q equal to charge Q equal to charge product of magnitude of a charge. The product of magnitude of charge is called Q. Okay, next R is equal to distance between positive and a negative charge ions. Distance between positive and negative charge ions. Positive and negative charge ions is called dipole moment. For example, H single bond F. Now the dipole moment is indicated like this. So it is a polar molecule. So now dipole moment is pulling towards fluorine. So it is a positive pole and it is a negative pole. So it is nothing but a dipole, two poles. So it is a dipole moment. Next you have to know applications. Applications of a dipole moment. So first one, it differentiate. Dipole moment is used to differentiating polarity of bonds. It is a polar or a non-polar. Okay, it is used to differentiating polarity of bonds. Okay, it is polar or non-polar, we may know. Next, if dipole moment is high, then polarity is high. Mu is high, then polarity also increases. Mu increases, then polarity increases. Then one more, nature of character means nature of bond character, we may know. Nature of bond character means it is ionic character or a covalent character, we may know. Means dipole moment is useful to knowing nature of character of the bond or nature of bond. Nature of bond. Nature of bond means it is covalent nature or ionic nature. So next, predict shape of molecules. Predict the shape of molecules. Predict the shape of the molecules. So these are applications. So what is the first application means? It is useful to knowing polarity of bonds. Then mu increases, polarity also increases. Nature of bond. Predict the nature of bond means it is ionic nature or covalent nature, we may know by knowing dipole moment. Next, predict the shape of the molecules. It is nothing but a prediction of nature of bond, we may say. Okay, so this is dipole moment and applications. It is polarity of bonds. So covalent bond is two types, polar and non-polar. Okay, so this is briefly about polarity of bonds and dipole moment. Next, we are going to discuss FAJAN'S rules. It is also very important question. FAJAN'S rules. Okay, this is also very important question. FAJAN'S rules. So, FAJAN proposed a scale based on electronegativity differences. Based on electronegativity differences. So, if the based on the differences, he proposed some postulates, some rules. By knowing these rules, you may decide the molecule is covalent or ionic nature. Okay, see here, first of all, you know example HF. So, electronegativity value of hydrogen is 2.1 and electronegativity value of fluorine is 4. This is hydrogen and it is fluorine. Okay, so delta En is equal to 4 minus 2.1, and then it is nothing but 1.9. Okay, then 2.1 3 plus 4. So delta En electronegativity difference is 1.9. So based on difference electronegativity of the two atoms, he proposed a scale. So that scale is nothing but a scale. This is a scale. It is a difference in electronegativity I am taking. It is a 0. It is a 1.7. It is a 2. Okay. If electronegativity difference is 0, this is 100% covalent. 100%. It is 100% covalent and 0% ionic. If it is 1.7, correctly 1.7, 50% covalent and 50% ionic. If it is a 2, means greater than 1.7, so 100% ionic and 0% covalent. Okay, electronegativity difference 0, 1.7 and 2. So less than 1.7 means like this, equal to 1.7 means like this, greater than 1.7 means like this. So he proposed some rules. What are the rules means? What are the rules means? The size of the cation increases. The size of the cation increases. Means covalent character decreases. Okay. Size of the anion increases. Covalent character increases. That is the first point. Size of the ion increases, then covalent character, then covalent character increases. Okay, size of the anion increases, then covalent character increases. For example, KF and Ki. So anion fluorine and chlorine, which is high size iodine. So covalent character of Kf is less than covalent character of Ki. Okay, then size of the cation, this is anion. Okay, size of the cation decreases, then covalent character increases. Okay, example, LIF and KF. So lithium and potassium cations. So the lithium size is less, means size of the cation decreases, then covalent character increases. So it is greater than. LIF is more covalent than KF. LIF is more covalent than KF. Then next rule. If you take charge on the cation increases, then covalent character increases. Charge on the cation increases, then covalent character means CC. Covalent character increases. For example, SnCl2 and SnCl4. Here it is a +2 oxidation state, it is a +4. So it is less than, means here it forms Sn +2 is less than Sn +4. It having more covalent character than this. Why? Because its charge is +2, its charge is +4. Then charge on the cation increases, covalent character increases. So +2 to +4 increases. So it having more covalent character. Next, cations having pseudo inert gas electronic configuration forms more covalent compounds. Okay, you know inert gas and pseudo inert gas. I am going to explain. See here, cations having pseudo inert gas, pseudo noble gas electronic configuration form covalent compounds. For example, here CuCl and NaCl. Here Cu plus 1, here Na plus 1. It having Ns2 Np6 Nd10 electronic configuration. It having Ns2 Np6. It is noble gas. It is a pseudo noble gas. It is a noble gas. It is a noble. It is a noble. It is a pseudo noble. Pseudo, it is inert gas. It is a pseudo inert gas or a noble, pseudo noble. So here it having Ns2 Np6 Nd10 electronic configuration. So 3 orbitals are fulfilled. So it forms a covalent compounds are more. Here Ns2 Np6 electronic configuration. It is a noble gas electronic configuration. So it is a noble gas electronic configuration. So it forms a less covalent compounds. It forms a more covalent compounds. Means comparing to this CuCl is great covalent character than NaCl. So these are rules, FAJAN rules. Okay. See here, what are FAJAN rules means? So based on electronegativity difference, he proposed a scale. So electronegativity, hydrogen electronegativity is 2.1. Fluorine electronegativity is 4. Then delta En equal to 4 minus 2.1, 1.9. So 1.9 means it is here. Then 100% ionic and 0% covalent. So between these two, ionic bond is formed. Between these two, ionic bond is formed. Then scale, delta En, electronegativity difference of the two atoms, 0, 1.72, like this. Then rules, size of the anion increases, covalent character increases. Size of the cation decreases, covalent character increases. Charge on the cation increases, Sn plus 2 is less than Sn plus 4. Charge on the cation increases, covalent character increases. Only we are discussing one character. One character increases means another one is decreases. Okay. Cations having pseudo noble gas electronic configuration form covalent compounds. Means copper and Na. Copper Cu plus having Ns2 Np6 Nd10 electronic configuration. Here it is having Ns2 Np6. Pseudo means d orbitals also fulfilled. Cations contains s orbital, p orbital, d orbital fulfilled electronic configuration are called pseudo inert gas electronic configuration. Okay. So here pseudo inert gas electronic configuration having cations forms covalent compounds easily. Means covalent character is high. Covalent character is high means at the same time ionic character is less, low. Okay. So this is briefly polarity of bonds, dipole moment, applications, and next FAJAN'S rule.